Hi folks, today I'd like to share with you a project of mine that I've been working on for quite a while, um, and it's called Houdini Engine Rust Bindings. So for those of you who are already familiar with Houdini Engine, you can skip this part, but for the rest I'll give you like just a brief overview of what Houdini Engine is and why it's a pretty fun piece of software to play with, and it's got a lot of use cases in VFX pipeline, in game pipeline. There's a lot of useful use cases we can think of. So as the documentation says, you can see it on the screen, that it basically enables you to load Houdini digital assets into the host application. And the host application is something where you integrate your Houdini engine, right? Is where you want to utilize Houdini functionality from within some application. This is the host application. And from the technical point of view, it's just a C API, and Houdini ships with Houdini HDK, which is a very massive C++ API that lets you write everything you want in Houdini. But the C API, and particularly the Houdini Engine API, it's a very narrow subset of functionality that you can do with Houdini compared to the full-blown HDK. But nevertheless, it's still quite powerful. It lets you do a lot of things in Houdini. And if you browse the documentation here, there's a fairly good docs in here, and you can see that giving just the title of those chapters, you can see what you can do with API. You can work with the nodes, with geometries, with attributes, parameters of the node, curves, volumes, do some instancing, extract materials, render to textures, um, cook PDG, and a bunch of other interesting things. So the C API being C, it's quite verbose, it's quite annoying to work with, very error prone, um, unpleasant. We all know that, right? And since you're here and listening about the Rust bindings, this is where this is where Rust comes in and plays a huge role into making the Houdini engine nice and pleasant to use. So this is the library that I've been working on. All right, it's a crate called happy-rs, and we are going to be talking about this library today. I'm going to show you a few examples, how to get started with it, what you can do with it, and um, a few demos as well. I have a few nice demos in here. One of them is on this page actually. Okay, so we're gonna start with just a very simple project. So I'm going to use the Rust rover. I'm gonna open it up and we'll start with a new project. Right, I'm gonna call it a PRS demo. So I have a Rust installed. I'm using the latest nightly. For the other project of mine, it's not actually important. You can use stable, the latest stable. It's going to be a binary. I'm gonna hit create. Um, and give it some time to load. Okay. All right. So first things first, we're gonna go to Cargetomo, and we are going to add happy.rs, and the latest is 0.9.3. So because the engine itself is it's a compiled library, right? It's a shared object, or DLL on Windows, SO on on Linux, which means that it needs to be loaded at runtime. And for that, we've got to do some setup on Windows and Linux. And the setup is described on the doc page. If you scroll to, oh, it's right here, right? In order to run it, in order to use the Rust bindings for Houdini Engine on one of the platforms, you have to do these steps. Like on Linux, you can use this command, or rather like this Rust flex environment variable, which gives you basically a path to where Houdini installed and the DSO lib within it. And then there's also an option too that you can create a cargo config file in your Rust project. And for Windows, you need to export the HFS variable, okay, pointing to your Houdini install, and the path variable. Okay, so I'm on Windows and I have those already exported. So if I'm on PowerShell, if I do env HFS, you see I have HFS in here. All right, so that means that my Rust rover, my IDE is running with this environment, and it knows where to find all the stuff. So we edit the happy RS. We're gonna go to main. So first things first, I'm gonna show you how to let's like explore the idea what the Houdini engine is when it comes to communicating with it and where it actually runs and what it means to be a client or a host application. So for that, I'm going to just start Houdini. I'm going to need the PowerShell again. I'm going to say Houdini core.exe. I'm going to start it. A few words about the license. I wanted to mention, in order to use Houdini engine, you need to have a commercial license. With the only exception is, there are two exceptions, the Unreal Engine and Unity. Those two plugins that ship with Houdini are available for free. So in order to use them, you need to have Indie, I believe it's called Houdini Indie license, or something along those lines. But if you want to use the third-party client or third-party library or third-party integration, which in case of Rust, it is a third-party integration, you need to have either an education license that is a very cheap one, or obviously you can go with a core license, FX license, batch license, whatnot. But it's not free, so just to be aware of it. Okay, so we are running Houdini now, and what do we? So what we need to do here is we need to start the server, and the way to do that is we need to go to the Windows menu and then Houdini Engine Session Sync. So there's a few options. We can start the TCP server or the pipe server. Most of the time you want a pipe server. It is nice to have a TCP option if you want to, run Houdini somewhere on the server in the headless mode, and you want to communicate with it via the socket. So in our case, it's going to be name pipe, call it happy, and that's it pretty much. Not going to do anything else. So next thing, we are going to create an asset. Going to be real quick. Going to create a subnet. I am going to actually, let's see, I'm going to put it right here. I'm gonna copy absolute path. I'm gonna say digital asset create new. I don't want any of these things. Okay, digital asset, custom path is going to be here. Prefix, and we call it demo. All right, hit create. So we should be able to see there's our asset. And we're going to create a simple parameter, like for example, where is it? Let's get a float. Let's actually hide everything, like the hide the transform and the subnet. Create a float parameter, call it float, float parm. Right? Just to show you the very basic what it means to create an asset and set the parameter values. All right? So now we get an asset. Let's save it again just in case. We don't actually need it. We just created it and created added a parameter to it. So we're going to delete the node. And now we're back to Rust. And once you update the changes, let's do that. Okay, while it's updating, let's start with bringing in the happy library. So I'm gonna say use happy rs star. Let's actually you can safely bring everything from the library, but I usually do like session star, and I do parameter star, and also use happy rs result. Okay, so our function is going to return result, and so I'm assuming that the viewers of this video are familiar with Rust, so I'm not going to explain any Rust specifics here. I'm assuming that you already know the basics. There's nothing crazy in here, but just the very basics. Let me actually try to make a font a little bit bigger. Let's say font. I keep forgetting where the settings is. Editor, appearance. Nope. I'm sure it was somewhere here. Use custom font maybe. 16. Let's see. No, that's the whole UI. No, we don't want that. All right. Hope it's good as it is. Not gonna bother with that. Okay, so we want to, after we brought all the types that we need from the library, we want to connect to the running session and start creating nodes, right? For that, we have a function called, let's actually call it session, and we say connect to pipe. This is the function from the session module, and let's see what it wants. It wants the path, and it wants some options. So what is the path? The path is actually a pipe file that we started in Houdini. So on Windows and same on Linux, you don't actually need to have like a full path, but technically it can be a full path, but rather it's just a pipe name, and we call it happy. The next option is session option. We can say none, and the timeout is none. The timeout is how long the client is going to be trying to connect to the server if it cannot do it on the first try. And we say, unwrap question mark. So let's see if we got the where's the debug macro I'm looking for. All right, let's see session, and we're gonna return OK. Let's see if we can make a connection. Start. It's gonna compile it, and there you go. You got the session and all the internals of the session, which is great. And you got this node gets automatically created by the client when it connects. There's nothing interesting, nothing useful in this node, but it gets created all the time. So cool. So we have a session. Let's try to load our asset into it. So for that, we say session load asset file, and we give it a path. The path is going to be, I believe it's relative to the working directory, so it'll be just demo, right? And it's going to be a question mark, and let's say it's a library. So the way I implemented it is when you load an asset file, it gives you the library back, and the library can give you the all the assets that are available in this HDA node. You can reference them by name, but it's much more convenient to just use the helper function that I created here. It's called try create first. So the thing is that most of the time you'll have just a single operator available in the node in the HDA file, and it will try get the first one available in there, and it will return an error if there's 0. So try create first will actually give us the node, and we unwrap it. So let's give it a go, run it, and we got some error. Okay, let's see what it says. Try create first. Let's actually see if we loaded the file debug lib. Let's first. I'm afraid that it might be not in that we might need to give it a full path. Yeah, most likely. Okay, let's give it a full path. So, oops, that's an ugly Windows path. All right, debug. There you go. So you got an asset, and then you want to create a node. Let's say run, and you can see we created a node. All right, cool. So the next thing we want to do is to set the parameter value. Let's say we want to set it to some value, and first of all we need to know that this is the float parameter type. And the way I implemented it in Rust is that every parameter is an enum, so you have to match on the parameter type. And the way you can do that, I mean, there's a multiple ways in Rust, like using the match statement, but the easiest one, I think, it's going to be if let parameter float parm, and we say node parameter and reference it by name, float parm, right? So if we match the parameter and it's a float, we get a reference to it inside. And the value would be let value going to be parm. Get value is going to be index 0 because the parameter can be multidimensional. So we want the value at the index 0, and let's say debug value. Okay. What does it say? Oh, okay. So this one can also return. Let me see. A result. Yeah. So we have to unwrap it. All right. We got the value back because the default value of the node is the parameter is 0. What I also like to do is I like to allow unused and allow dead code, so we won't get all the warnings while we developing. Okay, cool. So we got the value, but we also want to set it back, and that's easy, right? So we just set and say 3.3. It always unwrap and run it. So you got the node, and we set the value back. So the next thing, let's do a very quick update to our node. We want to say, I don't know, let's say torus. No, let's say grid. created a grid inside of it, and we say maybe add color to it, right? Point color, maybe random, and we save node type. Okay, so now our asset has a geometry inside. Let's try to get this geometry and I don't know, maybe save it to a file or just explore it and see what APIs are available for us for working with the geometry. So in order to get the geometry, there's a plenty of ways, because a single HDA node can have many sub objects inside, many geometries inside with many display flags. So if you know for sure which node in the container is exactly the one that you're looking for, its path, then you can obviously get it by path. But most of the time, you'll have a single node that has a display flag, and the other nodes are like auxiliary and just helpers, etc. So in order to get this display flag, you can say node geometry. So if you can see, it returns an option, the result, and an option. Result, obviously, it's whether an operation fails for whatever reason. An option is when you don't have a geometry, right? You can have a node without a geometry just fine. So we want to say let geo equal, and we're going to unwrap the error, and then we say expect geometry. I think it's going to be fine for our case, right? And as usual, debug geo. All right, so we run it, and we got the geometry back. You can see it prints out some debug information, but this one is like a C internal C struct, which is not super helpful when you look at the debug output, but at least it tells you that there's some geometry was found. Let's say what else we can do. We can have we can do a lot of stuff with the geometry. We can actually create attributes, delete attributes, inspect attributes. Let's try to what's that function that gets you all attribute names? Yeah, you can say this one. Let other names, geometry attribute names. Obviously, it's going to be a result. And this one is the owner of the attribute. So attribute owner, in our case, we created a color attribute on the points. So this will be a point attribute owner. And a partition, by default, you can get a partition by called geo. I think it's part info. Yeah, like that, and give it an index. Or you can say no, or like none, and this function will automatically query the partition with index 0. The partitioning, I'm not going to go into details. You can read about online. Is how the geometry is split in chunk and represented in the API. For heavy geometry, you can have a lot of partitions for that to kind of simplify processing. Okay, so what do we get back from it? We get a string array. This is like one of the API design choices that I had to make, because a string array is C strings are different from Rust strings. C strings are null terminated, and if you want to pass a lot of strings back and forth between C API and Rust API, you have to convert C strings to Rust API and vice versa. So when you retrieve a lot of strings, what I do instead is I'm creating like a special object, right, called string array, and this string array lets you choose which string representation you want. Like if you need Rust strings, you will be iterating over Rust strings. There's a method for that. Or if you want to keep using C strings, you can get the C strings if you want to, like, let's say, get the value from one array and pass it to um, rather get the values from one attribute and pass it to the other attribute. You don't have to convert it to Rust strings. Let's see how we can do that. Going to for attr name in attr names, and you can see there are a few methods in here: iter string and iter c string. I want to say iter string, and I want to debug attr name. All right. Oops, I hit the compile. No, I don't need to compile. Oh, that was a panic here. Okay, interesting. So we panicked, and we panicked, and probably we are doing something. Let me see. Get attribute names. Yeah, you want a partition. Do we even have a partition? Let's say it's been a while since I tried this one. Part, and we say geo. Oh wait, did we? Node not cooked. Okay, okay, this is great. This is great. Now we actually have a partition. Everything is all right with that. Node not cooked. This is something that you have to remember every single time you create a node. The first thing you want to do is actually to cook the node, because there's a lot of like smart caching happening on the Houdini engine side, and it won't cook the node unless it's absolutely necessary, unless you request the value. But sometimes it's not entirely clear when you want to cook the node. So it's most of the time it's a good idea to do this right after you create a node and right after you set the attribute values. So what we want to do here is we want to say node cook, and there's also a couple of things here you can do. You can just say cook, and you can say cook blocking, and it depends on whether you're running in asynchronous mode or synchronous mode, which is kind of a little bit outside of our scope of today's video, asynchronous cooking. But for most of the time, like for simple things, especially when experimenting, cook blocking is the way to go. So what it'll do inside, it will call cook in a loop and check the result until it's done. So cook blocking, and then after we set the value, I'm just gonna do the same. Got a cook blocking here, and let's see. There we go. So we got our attributes. So we got the P position, which is the point attribute, and we got a CD, which is the color. Okay, so I'm going to leave that alone, and let's say if I want to get the attribute and work with its attribute, I can say the very same strategy as with a parameter. No, actually, I'm taking my words back. I think for the attribute, I have a little bit different API in here. So let's say I want to get the CD attribute. In order to do that, I'm going to call a geo get attribute, and so the part ID is going to be 0, owner is going to be point, and the name is going to be CD. Okay, I'm going to unwrap and expect CD attribute. We know that it exists. Okay, so now the attribute itself, it doesn't let you do much, right? Because this is the kind of a generic attribute wrapper. You want to get to a specific attribute, which is the float attribute. More specifically, it's an array attribute of floats. So, and for that we have a downcast method. And let's say I'm going to override it right here, downcast, and I'm going to say I want to downcast to if memory serves me well, I think it's a float. Oh, let me actually bring in the attributes. Use up here as attribute star. Oh, quite frankly, I forgot how to downcast. Let me see the source code real quick. The attributes, string attribute array. Yeah, it should be there. Attribute array. Sorry guys, gotta check it out. Can't remember. This is a string attribute. This is the array attribute. Okay. String multi-array. Array either. Okay, let me do this. Let me do this real quick. I'm going to cheat in a way that I'm going to examples, which we are going to look into in a moment. Let me see. Curve Marshal maybe. There's a downcast. Nope. Downcast here. No downcast. Where are all my downcasts? Did I look here? Oh, there you go. Oh, okay. It's yeah. I remember that. It's a numeric array attribute, right? Is it a? I think it is. I think it's a numeric array attribute, and the type is F32. Okay, and because it's a cust, it returns an optional, and we want to say we are expecting a CD attribute, right? And let's try to debug a CD attribute. Is it doesn't implement debug? Oh, okay. Unfortunately, it doesn't implement debug, but we can say get pod info. Now we don't even actually need to debug it, just make sure that it compiles. It's not, because it's not a numeric attribute array, it's just a numeric attribute. Numeric attribute. Yep, I think it should be it. There you go. Okay, so we got the attribute, and yeah, so we can get the values, right? So let's say part ID, and it will return a vector of values. So we can say for value in unwrap this one and say debug value, right? And run it. And you can see we got all the color values from the geometry. All right, all these values are here. Now, similar, you'll have access to the set method, right? But we're not going to this now, but you get the idea. So we call set part ID, and then it wants what? It wants a slice of value. So it will be, I don't know, any values in here. You only need to pay attention that the length of the slice is equal to number of points multiplied by the size of the attribute, right? So the color is the three floats, but I'm not gonna do that. Okay, so here's basically the idea how you work with a geometry, right? There's few other things I would like to show you, but we're gonna wrap this example up with just the geometry. Like save to file, for example, you wanna, or you can save to file, or you can save to memory. This is a nice feature that lets you actually, cook the geometry and then save it to a memory. And if you can see, the return type of here is vector of I8, which is actually like on the C side is just a vector, array of character, just raw data. Um, and since it's in memory, you can do whatever you want with it on the host application. You don't need to go through the file route. Everything is in memory and it's going to be fast. But we are going to save to file and say, I don't know, C temp foo bgeo, and then the extension matters because it defines the file format, the compression. There you go, and we got the file in there. Okay, cool. So hope you got like an overall idea how to work with a library, what it lets you do. There's a lot of APIs available on all these nodes, with the session, with for the session, for the node, and the parameters, etc. You can see it's quite compact, um, in a way that it's still a little bit lower level sometimes. Uh, it feels sometimes like as a lower level library, but in a way, it also like a higher level compared to the C API directly. C API is a bit of a nightmare. So yeah, that's about it. Let's take a look at a few other examples that are might be interested to look at. I'm going to leave this one. No, actually, I'm going to close this one, and I'm going to show you how to just easily spawn a new session without connecting to an existing one, right? Because this was an example where we're using already running session, and it's great for interactivity, like for experiments like that. But when you write a tool, you want to spawn the server, right, from your code, and for that you say let session, and there's a very handy function that I created called quick session, and again you can say none question mark, and that's it. You got a session. Now all you have to do is hit run, and in the background it spawns the process which is called Hars, right? It's called Hars. It ships with Houdini, and it passes the um, pipe file name, like something like foo. There you go. It runs the Hars server. You can connect to this foo pipe. Let's say I can do this like here and say foo, right? And hit run, and everything is going to be working, right? Kill it. Control C. Come on. Come on, Windows. Oh, goddamn. Windows. Windows, I know you can. No, I cannot. Okay. It is really painful to work in Windows sometimes. Um, yeah, so connect to pipe is your, or rather like quick session is your friend when you want to do like some real quick experiments. Connect to pipe is to connect to a long running session. And options, there is a lot of session options that you can have. There's a builder. You can set the OTL search path. You can set the cook options, multi-threading. It's not like a multi-threading, but the threading in a separate, cooking in a separate thread that enables you to write like an async API. Um, you know, plugin search path, environment variables, etc. So a lot of things to configure. Okay, so I'm going to close this one, and we are going to the source code of the um, engine itself, rather like Rust bindings, and I'm going to open it up here, say this window, because I wanted to show you a few examples from this library. Okay, a few interesting ones. There's many of those are I just bought it from the existing C API, so they're not very interesting. They're just a straight port from the C++ code. I mean, obviously, like using this library API. But there are a few that we can look at. For example, let's see, live session. Okay, so live session is interesting when you want to experiment. It is pretty much the same as I showed you before. It spawns the Houdini instance and then lets you interact with it via the API. But it's a little bit more kind of convenient to use. So I'm going to say cargo run example, and I'm say live. What's it called? Okay, live session. All right. I hope it's. Let me see. Okay, pipe happy. Yeah, this should be fine unless the happy pipe is already in use, but it should be fine, I think. Okay, so what it does, it actually starts Houdini, right? And as soon as it starts Houdini, it actually enters a loop. You can see in here, it actually enters the loop and it constantly pushing new values into this node, right? You can see it's just a null node, and it's just pushing the values in a while loop. So we can take a look into there's actually like nothing like super crazy in here, but a few interesting things is that we set a handler, a control C handler that lets you either catch the control C signal, and I can do that easily. I can say control C, it's gonna stop, and then if I run the same example again, it'll connect to an existing session. It won't start a new one, which is quite handy. And you can play with the values here, like say, I don't know, you can say like radius multiplied by 2, right? You can restart it, and here you go. You got some other some different animation happening. Things like that. That's pretty much it. So what I like about this example is that it really helped me at work. And kind of on a side note, I don't use Houdini engine, Rust bindings to Houdini engine directly at work, but I do use and support and write a lot of like C and C++ APIs. Uh, you know, we all in this industry, we're all in C++ and Python. But I found that this library and especially this live session lets me experiment very fast and very effectively on the APIs that I want to put into the C++ code later, because of the all the properties of Rust and kind of just the convenience. The nice API lets me experiment with the values, with the parameters, and once I settle on the API, on the design, or whatever I want to achieve, I just write it in C++. I mean, like obviously not just write it in C++ with a little bit of struggle and pain, but yeah, it helps a lot. It helps a lot. So let's see. let's see another one. I'm going to close this one and I'm going to Control C. So here I am going to navigate to the apps folder, and I think we have RenderCop. Yep, and CD RenderCop. Say cargo run. Let's do a release mode. So this one is the RenderCop. Cop being compositing operator in Houdini that we all know. So, and again, Houdini Gen lets you create any kind of asset, any type of asset, and cook it and retrieve the results. And cops are no exceptions. So we created a cop network with a few noise functions in it, and you just have a parameter that changes the values, and you get the image back. Um, the cops are notoriously slow, so they are old tech, but they still useful nonetheless. As you can see, there's like a render time in about on the first render, it's more than 100 milliseconds, but then it caches the result and it's about 70 milliseconds. Yep. So just a little tiny example here that you can somehow maybe utilize. Another one is a little bit more fun. Let's say it's called a Viewport, and I'm gonna run it again. I just run it before the video, and it compiled already. Otherwise, it'll be compiling like about 300 dependencies. Yeah, so this is a simple viewport. It is not technically, although I imagined it initially as a viewport for the HDAs, and I might eventually write something like that. But at this stage, it's just a 3D viewport for the geometry, very handcrafted, hard coded, but it's still kind of viewport. It lets you zoom in, zoom out, and pan. See the model. You can switch to a different model, and you can inspect it. You can also, I believe I used to have animation on this guy. Maybe it was some dev version that I don't have anymore. Yeah, you can use deformation here as well. Everything is quite fast, but you still pay some penalty for transferring the data from the server to this application, because the server is running as a separate process and it communicates with this application via the pipe file. So you still kind of pay some performance for this conversion, but generally it's quite fun, quite fast. So we can see the cook time on the Houdini side took only 5 milliseconds, and then the match processing on the Rust side, so this is a pure Rust time, is 200 something microseconds, and the average API time is when the time that the whole Rust bindings took, like the whole round trip from the call on the Rust side, um, took 70 microseconds. So I think it's quite good. It's fast. All right, so that's pretty much it. There is another thing that might be very useful for some, but not so much for others, is PDG, and it's also implemented in here. I also covered the whole PDG API, I believe. Um, for those of you who worked with PDG, they know what it is, and it's quite a powerful beast. Lets you do a lot of cool stuff. It is available in the Rust bindings as well. It's a little bit more verbose. It's not like a super nice high-level API. You have to dig into code like this. But essentially, what it gives you, you say a PDG node, you say cook, and it'll take a closure with a cooking step, and then you gotta iterate this closure of this function is gonna be called on um, every event that comes from Houdini, and then you react to this event. You say, okay, so a new task was added on the Houdini side, or the work item, not a task, the work item has been removed, or the state of the work item has changed, and then you get the state and you say, okay, the work item succeeded, or it got the result from cache, which is also means success. You get the attribute, you get the results, you iterate over the results. The results are files, you get the files back. So quite cool. Um, you can do amazing like parallel computation with this. And yeah, and the last thing is something that I use rarely, but still it's nice to have. Um, is this run Python? Um, unfortunately, it unfortunately Houdini Engine does not let you run any arbitrary Python script on the server side, like in the engine itself. It only lets you put the Python script into the node and then expose the button on the node on the digital asset that you can press the button and it'll run Python script. But sometimes you just want to push some any arbitrary script into the engine and let it run. So there's a happy script HDA that I put together that lives in this library, which basically just a convenient OTL that lets you like push the script into it, and then you press the button. I call the parameter run. So this is how you do it, right? You get the parameter code, you push the script into it, and then you get a parameter button, and you call press button, and it just works. So nice convenient thing. You can run any Python script in Houdini engine as well. All right, I think that's pretty much it. Um, I think I covered everything I wanted. Um, Please feel free to reach out, ask any questions if you have. Maybe you'll get some inspiration about how you could use this library at work or just for fun, for hobby. I would like to hear about it. All right, thanks everyone. Take care.